Today we're going to hear Chapter 3 from I Am Albert Einstein. It's a miracle. If Albert didn't already know Marcel was a true friend, there was no doubt after Marcel helped him land a job. Albert's break came through Marcel Grossman's father, who was friendly with the director of the Swiss Patent Office. A patent is a government-issued document that allows an inventor to make and sell an invention, and it prevents others from copying it. Albert was hired by the director in 1902 to make sure that ideas that people sent in for new inventions actually worked. He became a citizen of Switzerland that same year. Thrilled, Albert promised in a letter to Marcel to do everything in his power not to disgrace his recommendation. No more bad attitude, Albert. This time he spent looking for work seemed to have given him a sense of appreciation. Patent clerk was a perfect job for him. Not because he loved going over other people's inventions. He did like looking for flaws in someone's argument, and a lot of subjects that people were working on, such as electricity and energy, excited him. But the best feature of his position, however, was the fact that it allowed him time to work on his own science projects. Because Albert was able to get his patent work done in roughly 3 hours, he had the rest of the day to spend on his experiments. Albert didn't need a lab to do his research, since it all took place in his head. He liked to call them thought experiments. He would come up with problems, imagine solutions, and then do the complex math to see if he was right. He did need lots and lots of paper for his math problems, but whenever anyone walked by his desk, he'd quickly shove the papers aside and pretend that he was doing his patent work. With a steady paycheck, Albert was finally able to marry Mileva in 1903, and just a year later they welcomed their first son, Hans Albert. Although Albert wanted Mileva to continue as a scientist, and I do apologize if I'm mispronouncing her name. Although Albert wanted to continue as a scientist, she failed her exam for a second time, and so instead he focused her efforts on just taking care of Albert and their new child. Meanwhile, Albert was concentrating all of his efforts on making the biggest scientific breakthrough of the 20th century. He continued to be fascinated with light and the new study of particles in electromagnetic theory. The problem that was bothering scientists had to do with electromagnetic theory, equations that describe how electricity and light and magnetism work. Experiments proved that light always traveled at the same speed. But this contradicted Newton's laws of motion and the basis of all physics, which stated that speed changes under different circumstances. Scientists found over and over again that the speed of light doesn't change. Still, Newton couldn't be wrong. What was the answer? Albert happened upon it in his streetcar. There was a big clock tower he always looked at during the ride, but one day it got him thinking. If he traveled away from the clock at the speed of light, light from the clock face would never catch up with him, and so the hands would appear frozen in time. However, if he traveled at the speed of light while wearing a watch, the timepiece on his wrist would be moving with him at the same speed, and it would appear to tell time normally. This was the beginning of Albert's really big idea, which is the principle of relativity. Relativity means comparing one situation or object to another. In Albert's case, how things appear is relative to the person looking. It was the birth of a brand new concept of how space-time work together. So let's take a break from the story. This little, what is this? What the? If you read about the special theory of relativity and all the words made sense, but you still don't understand it, you're not alone. Most scientists couldn't understand it at the time, and most people still can't. That's because many of Albert's theories were counterintuitive, meaning they were opposite of what makes sense to us. And when physicists do math computations and observe physical phenomena, they work. However, they're hard for us to imagine. So it's okay if that's not making a lot of sense to you right now. After the idea struck, Albert set to work furiously and in only 5 weeks had written his paper on the special theory of relativity. In it, he argued that if the speed of light doesn't change and Newton's laws of physics don't change, then the element that does change is time. So if you're traveling at the speed of light, time stands still. Space and time are connected as one, space-time. So what was the response from the physics community to Albert's special theory of relativity and his other three papers in 1905? Well, scientists basically ignored his work, which was difficult to imagine, and it went against common knowledge. Critics, or lack of them, had never stopped Albert before, and they didn't stop him then. The following year, he published 6 more papers, and in 1907, 10. Still, no school wanted to hire the patent clerk, not even as a high school math teacher. Slowly, Albert's ideas began to take hold. As other scientists set about proving them on a small scale in labs and using them to further other theories. Those were the goals he always had for them. Finally, in 1909, he was offered the job that he'd been hoping for ever since he left school, an academic position. At the University of Zurich gave him a newly created position, Professor of Theoretical Physics. The university's newest junior professor wasn't the most organized teacher. Often his lectures were little more than scraps of paper in his pockets. What he lacked in order, he made up for in enthusiasm. He encouraged the same curiosity in his students that others had tried to stifle in him. That included letting them ask questions during class, which was a big no-no back then. Albert spent a couple of years in Zurich becoming a full professor at the University of Prague. His paycheck was twice as big, which was good, because now he had twice the number of kids. His second son, Edward, was born in 1910. With a new salary and a new home, the Einstein family got to enjoy such comforts as electric lights. In his new job, Albert's colleagues were many of his science heroes. Not only his work life, but also his social life revolved around a set of the biggest, most important thinkers at that time. Life was good for Albert, except for one fact. He and Mileva weren't getting along at all. The Einsteins moved back to the city where they had once been so happy because the Polytechnic had finally offered Albert a position. But they were far from happy now. By this point, nothing could repair their marriage, not even returning to Zurich where they had fallen in love. Mileva was often ill and fought with Albert all the time. Albert responded by spending more and more time alone, either traveling or working in his room. In 1914, Albert changed jobs again. The University of Berlin offered him a position where the only requirement was for him to think and work on his ideas. Although he wasn't a big fan of Germany, Albert couldn't pass this up. His wife tried moving to Berlin, but their relationship in the German city was even worse. She quickly returned to Switzerland with her 2 sons, Hans and Edward, and eventually she and Albert divorced. While in Berlin, Albert fell in love with Elsa Lowenthal. She was actually Albert's first cousin. He had struck up a friendship with the divorced mother of 2, and it grew into a relationship. Nevertheless, Albert was still sad about losing his family, and he threw himself entirely into working on his biggest scientific project yet, the general theory of relativity. So that's where chapter 3 ends. I did skip one page, which was the miracle year, that I'd like to read to you very briefly before I end my recording. In the same year that Albert published his papers on the special theory of relativity, he also published 3 others that changed science forever. That's why people later called it his miracle year. Here's a snapshot of the 3 other papers. Paper number 1 was about the photoelectric effect. It explains what light is made of and how it moves around. Paper number 2 is the true sizes of atoms. It proves that atoms and molecules exist. And paper number 3 was focused on mass and energy and that famous equation, E equals mc squared. E is energy, like heat, light, and sound. M is mass, the amount of matter or stuff that makes up something. And C is the speed of light, which is 186,000 miles per second. Thank you for watching Chapter 3 of the I Am Albert Einstein book.